We're going to look at radicals and rational exponents. So first off, we're going to find some roots of some radicals. This is a cube root of 8. So anytime you're breaking down a radical, you want to break it down into its prime factors. And then since the third root, I can take the cube root of anything that I have 3 factors of and get my original value back. So the cube root of 3 factors of 2 is just going to be equal to 2. If you have a negative, like the negative 125 inside of this cube root, there's just a few ways you can think about it. An odd number of negatives will get you a negative number when you multiply. So you could think of negative 125 as negative 5 times itself 3 times, which means the cube root is negative 5. Or you can think about it having a factor of negative 1 times the positive 125. And then you could break down your 125 into 3 factors of 5, and then negative 1 is an odd number of negative 1s, and get negative 1 times positive 5 is negative 5 that way. The sign of an odd root should match the sign of your original value inside of it. If I'm thinking about square root of negative 16 though, 16 breaks down into 4 times 4. There's no real number times itself that'll get you a negative. So if you remember from Algebra 2, this is going to be 4i. But the directions ask us to find any real roots. So that just means we don't have any real number roots. This is the review section of your Precalc Algebra book, and they're acting like you don't know about imaginary numbers yet. So exponents don't have to be whole numbers. They can be rational numbers or fractions. So say you have x to the 3/2 power. That's actually a radical in disguise. It's the same thing as having the square root of x to the third, or having the square root of x all raised to the third power. The denominator is the index on your radical, and the numerator of that fraction is your power. So I can switch back and forth between radical form and rational exponent form. This is 7 to the first, and it's inside a 9th root. So this should be 7 raised to the power of 1 over 9. On B, if you don't have an index on your radical, remember it's 2, it's a square root. So this is x to the 5 over 2. I'm going to skip A. On B, you have to be a little bit careful because remember that's negative 1 times 32 to the 3/5 power. Order of operations, you're raising your 32 to the 3/5 and then multiplying it by a negative 1. So I'm going to have my negative 1 outside, and then I'll have my 5th root of 32. I think it's easier just to cube it on the outside so that I can break down 32, which is smaller, instead of 32 cubed. So if I do break that down, there are 5 factors of 2, so the cube root of 5th root of 32 is just 2. And then I still have to take that to the 3rd power, which gives me negative 8. The difference on C is that the negative 16 is grouped with that parentheses and it's all being raised to the 1/2. So that would give you a negative 16 inside your radical. But again, if you're just looking for real valued roots, that's 4i raised to the first. So you can say no real roots because that'd be an imaginary number. Simplifying something with rational exponents is exactly the same as what you do if your exponents were whole numbers. So you could subtract your exponents on your like variables and end up with x to the 1/3 power. Those were nice because they had common denominators already. The negative 4/3 power bumps that up to the top, and then I'm multiplying y to the 3rd times y to the 4/3, which means I need to add those exponents together. So if you add those, you're going to need a common denominator. So you're going to multiply that by 3 over 3 on your 3, which is going to give you, whoops, I wrote 12/3. I was thinking about 4s. Going to give you 9/3 plus 4/3, or y to the 13/3 power on top there. So you're just going to end up with 3x to the 1/3, y to the 13/3 when you simplify that one. So just because they're fractions doesn't make them work any differently than what you're used to with your normal exponents. Let's switch some from one form to another. Now remember, the only thing that has your exponent is the x there. So the 7 should be out in front, and then the 3rd root of x, since it's the 1/3 power. On B, 8x squared is all raised to the 2/3, so it should all be inside your radical, and it's going to be the third root of that to the second power. So if you break down cube root of 8, it's going to give you 2, and then there are only 2 factors of x inside there, so I'm just going to leave that. Now I do need to go ahead and square it, so 2 squared is 4, and then that means I actually have 2 cube roots of x squared, because that's being squared as well. So let me go ahead and write that out twice, because we can simplify a little bit more. This makes it easier to see. So I can multiply those together and give me 4 factors of x inside of my cube root. And then that means there actually are enough factors to do the cube root of an x to the third and still have one more x left over on the inside. So I'll have 4x times the cube root of x. This one you have just the 2 plus w being raised to the 2/5 power. So the 2 plus w is going to go inside of your 5th root, and then the whole thing's to the second. I can't break down that 2 plus w at all because those are a group. I could also write it as 4 times the 5th root of 2 plus w squared together inside.